How's it going, guys? Today in this video, we're going to be going over 13.3, day 2. That's wrong. 13.3, exponential decay functions, day 2. And in this video, we're going to be learning how to go from a transformed decay function into a graph and how to go from a transformed decay function graph into the equation. So for number 1, we have g of x equals 3 times 1/2 raised to the x minus 2 minus 2. Our transformation rule is going to be the same transformation rule that we had for growth functions. They're both still exponential functions at the end of the day, so they're going to behave relatively similarly, and they're going to have the same transformation rule. So it's still going to be x plus h, comma ay plus k. And to figure out what our transformation rule for this problem is going to be, let's list out our parameters first. Our a is going to be 3. Our b is what's underneath, or sorry, not underneath, what's inside of the parentheses. It's 1/2. Our h is going to be 2. It's what's with the exponent, so it's x minus h. So in this case, it's positive 2, and our k is negative 2. So our transformation rule for this problem is x plus 2, and our a value of 3, y plus k, or minus 2. So that's our transformation rule for this problem. Our domain, it's an exponential function, so it's still going to be all real numbers. So it's negative infinity to positive infinity. And before we find out our range, let's figure out our asymptote first. Our asymptote is always y equals k. So for this problem, our asymptote is y equals negative 2. So our range is going to depend on our k value and our a value. If our a is positive, that means we did not reflect it over the asymptote, or over the x-axis rather. So if we didn't reflect it over the x-axis, we're still above the asymptote. So if a is positive, we're above the asymptote. So we can say that the function of y is greater than the asymptote at negative 2. But if a was negative, we'll say the function of y is less than the asymptote of negative 2. But in this case, a is positive, so y is greater than your asymptote, y is above it. So y is greater than negative 2. For the point 0, 1 that we need to transform, we're just going to plug that into our transformation rule and see what it gives us. See what it gives us when we do that. So 0 plus 2, and then 3 times 1 minus 2. We plug that in. We get 2, comma 1. And then for our other reference point, negative 1, comma 1 over b. Before we actually transform this point, we need to figure out what 1 over b is going to be. So we get negative 1, and our b value is 1/2. So we have 1 all over 1/2. And that's just going to be negative 1, comma 2. Anytime you have 1 over another fraction, just flip the bottom fraction, and that's what you get. Another way to look at it is that we have the point 1 over 1/2, right? That's the same thing as saying 1 over 1 divided by 1/2. And anytime we're dividing fractions, remember, flip the second number, then multiply. So that's the same thing as saying 1 over 1 multiplied by 2 over 1, which is 2. That's what's happening. So that's why all you do when you have 1 over another fraction is just flip that bottom fraction, and you get a simplified version of that number. So 1 over 1/2 is just going to be 2. And at the same time, 1 over 1/3 will just be 3, and 1 over 1/4 will be 4. That's how it's going to work. So we have this point of negative 1, 2, and that's what we're going to transform. So we're going to plug that into our transformation rule. So we get negative 1 plus 2, then 3 times 2 minus 2. And that's going to give us 1, comma 4. So now we have our asymptote and our 2 transform points of 2, 1, and 1, 4. All we have to do now is plug them into our, not plug into our function, but put them into the graph, plot our points, graph our asymptote, and we'll have our function. So our asymptote's at y equals negative 2. We're always going to graph our asymptote first, and now we're going to plot both of our points. We have 2, 1, and we have 1, 4. And since our b is between 0 and 1, we know it's going to be a decay function without it even telling us. So we know the shape of the function is going to be increasing then decreasing into the asymptote. Since our A is positive, we're starting on the top, and we're decaying into the asymptote. So that's how our function is going to look like. And just to touch on that really quickly, what I said about B, if B is between 0 and 1, that's a decay function. But if B is greater than 1, that's going to be a growth function. So that is something you need to know, since we're not always going to, or we're never really going to tell you if it's a decay or a growth function. You should be able to see the equation and know by yourself. And that's how you know. If B is between 0 and 1, it's a decay function. And if B is greater than 1, it's going to be a growth function. And remember, for exponentials, B cannot equal 1. All right, for number 2, I want you guys to try it out yourselves. We've done stuff like this all year round, so you should be somewhat comfortable with it. If you need to rewatch this problem, please do so, but pause the video and try number 2 on your own. All right, this is what you should have gone for number 2. Your A is -1, your B is 1 over 10, your H is -2, your K is 8. Your transformation rule, it should have been x minus 2, comma, negative y plus 8. Domain is always going to be all real numbers, negative infinity to positive infinity. Before we find our range, our asymptote is y equals k. So that means our y equals 8. And our range, since our a is negative, our function of y will be less than our asymptote of 8. So y is less than 8. Our first reference point of 0, 1 transforms into -2, 7. And our second reference point of -1, comma 1 over b, that's going to be -1, comma 10, since 1 over 1 over 10 will give you just 10. And that's going to transform into the point -3, -2. So when you graph your function, it should look something like I have over there on the graph. And we're plotting the points -2, 7 and -3, -2 only. And like I said in the previous slide, here's the mathematical reason of why 1 over 1 over 10 gives you 10. All right, let's keep on going. On this page over here, we're going to go from a graph into our function. So the very first thing that we see is that our asymptote is y equals 4. It's a little blurred, but it's saying the asymptote is at y equals 4. Our asymptote is always in the form y equals k. So our k value is 4. For our reference points, before we actually go in and start filling these out, we need to figure out which parent function point goes with which reference point in our graph. So our two parent function points that transform into our points on the graph are 0, 1 and -1, 1 over b. So we need to figure out which parent function point goes with which point on the graph. And we're going to figure that out by comparing our x's with each other. So between 0, 1 and -1, comma 1 over b, 0, 1 has the bigger x value. 0 is bigger than -1. So 0, 1 has a bigger x value than the other parent function point of -1, 1 over b. And between -3, 1 and -4, 2, between these 2 points right there, -3 has a bigger x value than -4. So the point -3, 1 has a bigger x value than -4, -2. So the point 0, 1 transforms into the bigger of the two x values on the graph, which is -3, +1. So the bigger of the two x values between the two parent points goes with the bigger of the two x values of your reference points on your graph. So 0, 1 goes to -3, 1, since 0, 1 has a bigger x value than -1, 1 over b, and -3, 1 has a bigger x value than -4, -2. Bigger x value with a bigger x value, smaller x value with a smaller x value. So that's how you figure out which reference points goes with which reference point goes with which reference points. So the first reference point, back to our blanks over here, that's going to be -3, 1. Remember the point 0, 1, that's what we call our first reference point, and that transforms into -3, +1. So another way to say that is the point 0, 1. When we put that into our transformation rule of x plus h, ay plus k, is going to shoot out the point -3, 1. 0, 1 into the transformation rule transforms into -3, 1. So what that's also saying is that when you have an x value of 0 and you put that into x plus h, it's going to give you the point -3. So 0 plus h gives you -3. Or in other words, h equals -3. And we can put that in our blank over there. So when our x is 0, because this is in the form xy, when your x is 0, you put that to your transformation rule, you get 0 plus h, and that gives you your transform point right here of -3. And now we're going to do the same thing for our y value of 1. So when y is 1, and we put that into our transformation rule of ay plus k, we get a times 1 plus k gives us this transformation, or this transform point of 1. So we know what our k is. Our k is 4. We got that from our asymptote. So you know a plus 4 equals 1. And if we solve for a, we get that a equals -3. So we know our a value. And if we were to fill out this point, this blank, sorry, right here of a plus k, we know that's right there. A plus k equals 1. So another way to look at this is that our first reference point of 0, 1, the transform point of that first one gives you h, or the x value of the first reference point gives you h, and a plus k, you get that from your y value. And when you set a plus k equal to that y value of 1, you know our k from our from our asymptote. All you have to do is solve for a from there, and we did that. We got that a equals -3. Our second reference point, that's going to come from, or it's going to be -4, -2. And like we said in the beginning of the video, or not the beginning of the video, but in the beginning of this problem, that came from the point -1, comma 1 over b. That point transformed into -4, -2. So like before, we can say that the point -1, 1 over b, when you put that into your transformation rule of x plus h, ay plus k, that's going to give you your reference point that we have from our graph, -4, -2. So we can say that when x, because this is the point xy, when our x is -1, and we put that into our transformation rule, we get that x value of -4. So we can say -1 plus h will give us -4. And if you solve this out, we already know what h is. So really, I don't know why I'm doing this. That's a mistake. We don't need to bother with that, to be honest with you. Since we already solved for our h, we don't really care for our x too much. So we don't really care too much about that first point. So we're going to kind of skip that part, because what's important over here for our second reference point is solving for our b. All right, so our b point is the reason why we still use our second reference point, because we need to figure out what b is. We have our a, our h, and our k. We still need to solve for our b. So when our y value is 1 over b, and we put that into our transformation rule of ay plus k, that gives us -2. So that's the point of the second reference point. Our y is 1 over b. So we get a times 1 over b plus our k gives us -2. Or a over b plus k equals -2. So you can fill out our blank over here. A over b plus k gives you -2. And that comes from the y value of your second reference point. Like I said before, the x value of your second reference point isn't really all that important, since we solve for our h and our a from the first reference point. So all that's left here is to plug in our a and our k, since we know what those are, and solve for b. So our a, we said that's -3, so that over b plus our k value of 4 gives us -2. So let's continue this on down here. -3 over b plus 4 equals -2. We can minus 4 on both sides to give us -3 over b gives you -6. We're going to multiply by b on both sides. These cancel. -3 equals -6 times b. divided by negative 6. Negative 3 divided by negative 6 is a positive 1/2, and that equals b. So we have our b now, and we also have our other parameters of a, h, and k. We solve for all of that. So all that's left is just to plug it into our equation and finish up this problem. So g of x will equal our a term of negative 3 times our b that we just solved for of 1/2 raised to the x minus h, or x plus 3, since x minus negative 3 is x plus 3, and then plus our k value of 4. Our domain in set notation is going to be every x value such that negative infinity is less than x, which is less than infinity. And then our range, that's going to be every y value. And to figure out what our range is going to be, we're going to look at our a value and our k value. Our a value is negative, so that means our function is going to be below the asymptote. We reflected it over the x-axis, so we're below the asymptote. So we can say the function of y is less than the asymptote at 4. It's not fully correct since y isn't really a function, but for this case, I think it makes it a little easier to think of it this way. Our function of y is less than the asymptote of 4. But anyway, that's the video, guys. There's nothing else really to go over for the notes, and hopefully this helped.